Presentation. Mm, Okay. So hope you can remember in the last class we have discussed the algorithm to find the linear time median finding algorithm. Okay, to find the median, that is kth smallest element, and where the worst case time complexity is linear. So in the last class means I have provided you one video lectures. I don't know that whether you have watched this or not, but it was about the randomized algorithm, and this is in your syllabus. You can check it. That at the end of the syllabus there is a topic randomized algorithm, and the randomized analysis of randomized quicksort is there. Why I have given this? Because whenever we are talking about the linear time complexity of this median finding algorithm, we have used the randomized version of select, that is the partitioning algorithm. Okay, and to get the clear picture, I have supplied this lecture. Those who have not yet watched or did not get the time to watch, so please read it or check it, because it is in your syllabus. So later I will not repeat it till if you say that we have some problems. Okay. So there, for a recapitulation, what we did, we have used the partition algorithm of quicksort, and we have seen that if we can place the pivot element in its proper position so that left hand side contains the values less than the pivot element and the right side is containing the values greater than the pivot element, we are considering all elements are unique. Then if we want to find the kth smallest element, then this I let, this index is I, so it may be k equals to I. If yes, then we have got the solution. If k is less than I, that means we want some value. Say let I is 7 and we want to find the fifth smallest element. So fifth smallest element means it will be in the left side, which is less than this. So k is less than I means we have to search the element in the left side. If k is greater than I, then we have to go to the right side. And if we go on continuing this process recursively, then we will find the solution. Okay. So what is the time complexity? The time complexity we have written expected time complexity. Please keep this in mind. Expected running time Tn we have got is order of n. Already we have shown this. But there is a little problem. That means if all the elements are in sorted order, then always we will get Tn is equals to T1 plus Tn minus 1. Always. And if we solve this recursion, we will get Tn equals to order of n square. Therefore, in worst case, this algorithm is not linear in nature. Okay. Though the expected running time, that means on an average, we may expect that the time complexity is linear, but in case of worst case, this algorithm will exhibit order of n square time complexity. Okay. So our target was to find an algorithm where the worst case time is also linear in nature. Okay. So for this, what we did, we have taken n number of elements and we have divided this element into, again I am drawing because for analysis we require this one. Okay. So let we are having n number of elements, it is better to go for odd number of values. So let us this. So n is equals to, you can also consider this one. So here n is 5, 4, 5 into 4, 20, 24. Okay. So we are dividing this list into n by 5 number of groups. Check this. This is the ceiling value. Okay. So here in this case 24 by 5 is 4 point something. So ceiling value is 5. Therefore we are having 5 number of groups. Now we are applying insertion sort to the each group. Okay. Algorithm stepwise in this way, that first we are dividing the list in this way. Number one, dividing the list into n by 5 number of groups, each containing 5 elements. This is fixed. Number two, we are applying, say, insertion sort or any sorting technique. Insertion sort is better because there are small number of elements, only 5. To find the median of each group. So here if we sort all these elements, we will find that these are the median of each group. Okay. Then number 3, apply sorting to sort the group. Okay. So that means based on the median. So we are sorting these elements and accordingly the groups will be sorted. Think about this. These elements are already sorted. Now if we apply a sorting techniques and sort these 5 elements 1, 2, 3, 4, 5 medians, then what we will get? These groups will be reshuffled and this one will be the minimum. This is the second minimum, third, fourth and fifth in this way and so on if there are n number of elements. Then what we will get? We will get the mid value as the median of medians. Okay. So we will get median of medians and let us denote this value as x. Okay. So what we are applying? We are applying to the n minus 5 number of groups repeatedly or recursively to find the median of medians x. Now fourth, if this x, let the index is I, if this I is equals to k, then we have got the solution. If I is less than k, that means I is less than k, so you have to go to the right side of the partition as previous. If I is greater than k, we have to go to the left side of the partition. Okay. So in this way, and fifth, recursively apply the same technique. Recursively apply for the rest of the either left side or right side in this way. Okay. So if we go on doing this after a finite number of times, obviously we will get the kth smallest element from the list. Okay. Because we are finding this I value and ultimately we will be able to find the kth smallest element. Now the question is that what will be the time complexity of this algorithm? So before finding, we are having, see, two recursive call. One is here, another is here. Okay. So one recursive call is to find the median of medians. Another recursive call is to, if I is less than k, recursively we will call the algorithm with the right partition. If I is greater than k, we will call the same algorithm with the left partition. So we are having two recursive call. Now here the number of elements for the recursive call mentioned in third statement is fixed n by 5. But what will be the number of elements in the fifth statement, that is second recursive call? Here you see we are trying to find the worst case time complexity. Okay. So whenever we have sent the list as a sorted order, what we have got? We have got that the division is 1 and n minus 1. So the larger side of the partition is containing n minus 1 number of elements. Similarly in the next, again 1 n minus 1, again 1 n minus 1 and so on, that is n minus 2, n minus 3. But if we consider the size of the subarray as n, then it will be divided as 1 is to n minus 1. Okay, not 1 and n minus 1, 1 is to n minus 1. So the larger partition is containing n minus 1, and that's why the time complexity is order of n square, right? So here we have to find what will be the number of elements in the larger side of the partition, right? So how to find? Let us check this. Okay, what will be the number of elements in the larger side of the list? So again I am drawing this one because it will be required. 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, sorry, let this. Or we can consider some more values. 1, 2, 3, 4, 5, 6, 2, 3, 4. Let us this. Okay. So here we have already found that this is the median, and let us denote this as x. Now think about that. What is the minimum number of elements that are greater than x? Let us find minimum number of elements that are greater than, or that must be greater than x. Think about that. What we know, if this is x, then this element is greater than x because all these are in sorted order. Now, since again these are in sorted order, therefore these two elements are also in sorted, and therefore these three elements are greater than this. Okay. So in one group we are getting three elements. These three are also greater than x. Similarly, these two are also greater than x, and these two are also greater than x. These must be greater than x. There may be some other elements which are greater than x, but these elements are mandatorily greater than x. Okay. So the difference is that these elements are mandatorily greater than x. So what is the number of these elements? Okay, how many number of elements are there in this group? So how many groups we are getting? We are getting n by 5. This is the total number of groups. So half in the left side, half in the right side. So half of these are containing some elements which are obviously or which must be greater than x. Now from this group is containing two elements which are greater than x, excluding this x. Okay. So we can exclude this one group, and here there may not be all the number in this group. So last group may not contain all the three elements. Okay. So we are excluding these two groups. One, the group which is containing the x, and the last. Okay. So these groups are containing three elements each which are greater than x. Listen it very carefully. So we are having half number of groups which are containing elements, okay, greater than x. We are excluding the group containing x because there are two elements, so these are not containing three elements, and here also there may be less than three elements in this group. So we are discarding these two elements and multiplying 3 because this is containing 3, this is containing 3, if there are some others containing 3. So we can say there are at least 3 into half of n by 5 minus 2 number of elements which are greater than x. So we can write this is less or not less, we can write greater, and this is greater than equals to, we can write 3n by 10 minus 6 because ceiling value of n by 5 is always greater than n by 5. So from here we can write that there are at least 3n by 10 minus 6 number of elements which are greater than x, right? Similarly, in other side, we can say that 3n by 10 minus 6 number of elements are there which are at least less than x by the similar, and this will be this group, okay? These groups are containing the elements which are less than x, and we cannot say about this group and this group, okay? These are not feasible to say that what are the properties of this element, but we can say the property of these elements and this element, right? So if we place x such a way that the left partition is containing less than x and right partition is containing greater than x, then this group is containing 3n minus 6, okay? Therefore, the right partition is containing 7n by 10 plus 6, because n minus 3n by 10 minus 6, this will contain the other partition. So, if we consider that 3n by 10 minus 6 is the number of elements which are less than x, then the right partition is containing 7n by 10 plus 6. If we consider that 3n minus 10 by 6 is the number of elements which are greater than x, then this partition is containing 7n by 10 plus 6. So in either way, the larger partition is containing 7n by 10 plus 6 number of elements. Think about that. So the larger side of the partition is containing 7n by 10 plus 6 number of elements. Okay. Therefore, we can write the recurrence as Tn is equals to Tn by 5, because for all the n by 5 number of groups, whenever we are dividing this, we have to find the median of medians, okay? Plus T into 7n by 10 plus 6 plus, see, if we apply insertion sort to each group containing 5 elements, time complexity will be order of n. Why? Because to sort 5 elements, the time complexity is 1, and we have to go for n by 5 number of groups for each. So this will be order of n. Okay. So if we apply insertion sort for a fixed number of elements, just think about fixed number of elements. So the time complexity for sorting is order of 1. Since we are having order of n number of groups, that is n by 5 number of groups, so to sort the elements, that is to find the median of each group, we require order of n. So the time complexity is, we can say, not the time complexity, the recurrence can be written as T n by 5 ceiling value of this and T 7n plus 6 this, and for n greater equals to n0, okay, and this equals to constant time if n is less than n0. We will find this value n0 later after, okay. So I think up to this is clear. If you have any doubt, please note. After the class again we can discuss, right? So this is the recurrence. Now let us solve the recurrence. So I am erasing this first, and after that I am writing. So the terminating conditions I am deleting. We will find this n0 value, okay. This equals to, or maybe less equals to, we can write. See, n by 5, ceiling value of n by 5, right, before that, let Tn is equals to big O of n. Therefore, we can write Tn is less equals to some constant into n. So therefore, if we replace this value, Tn is less equals to some constant into n by 5 plus C into 7n by 10 plus 6 plus A into n. Here you see this is another constant, okay? This constant and C is not same. This is another constant an. So we can write C into n by 5 plus 1 plus C into 7n by 10 plus 6 plus an. And that equals to 7 and this. So we can write 9cn by 10, okay, plus C and 6c, 7c plus A into n, and that equals to, we can write C into n minus Cn by 10 minus 7c minus A into n, and that can be written as less than C into n if Cn by 10 minus 7c minus an is greater equals to 0. Okay. If this is greater equals to 0, then we can write that this is less equals to Cn. So Tn is equals to big O of n, that is order of n in worst case, if this condition is true. So this condition is true means if we solve this one, we will get that this implies C is greater equals to 10 into A into n by n minus 70. Okay, and for the minimum value of n greater equals to 140, we will get n by n minus 70 is less equals to 2. Okay. For others, any values, if you consider n equals to 70 and less than 70, all are negative, so therefore C is positive, it cannot be negative. So if you consider n equals to 70, this value is divided by 0, so infinity. If you consider n equals to 71, see this C is 71 into A into 10, so 710. So therefore, if we consider this value n equals to 140, we get the least integer, which is 2. Okay. So that's why we are getting this n0 as 140. So 140 is the minimum value for which this recurrence will hold. Okay. And for this one, we can say that C is greater equals to 20 into A. So whatever constant you consider here, if we consider 20 multiplied by this A and C is greater than this, then the recurrence will hold true, and therefore we can say that the solution or the time complexity of algorithm is order of n, which is worst case. So therefore, this algorithm is giving us the worst case linear time. Okay, so that is all about linear time median finding algorithm. If you have any problem, if you have any doubt, please you can ask. Otherwise, I will move to the next. Do you have any question? Any doubt? Please check the book by Coleman. That is CLRS. Are you there, or just you kept your mobile on and you are doing something else? I think you are not attending the class. So therefore it is better to leave. Okay, so I am leaving. From the next, I will think that whether I will take your class or not.